Alright, in this last video I want to talk about osmosis. In osmosis, it's just a special type of diffusion. So the substances are still going to be going from a high concentration to a low concentration. But in this case, in this very special case, it's when only water can move from a high concentration to a low concentration, but the solutes that are dissolved in the water can't pass that membrane. So your cell is surrounded by a membrane. But in this case, only water can move in or out based on the solvent concentration, on the water concentration. So in this case, you only care about and only know what's going to happen by looking at the percentages of water. So in this particular case, water in the solution surrounding the cell this is 90% water, and the other 10% is salt. Solutions have to add up to 100%. Inside the cell in this particular case, the solvent concentration is 95%. There's 95% water. So even though 10% is greater than 5%, solutes can't go across the membrane. They are blocked. So we can only look at the water concentration to figure out where things are going to go. And the water is still going to move from high to low concentration. So because 95 is greater than 90, in this case, water would move out of the cell and into the solution. And this would actually cause the cell to shrink a bit because it's losing some of that water. Remember, one of the roles of the cytoplasm is to give shape. It doesn't always have to be in this configuration. Sometimes outside the cell will be more than within. So let's look at a few other cases of osmosis. So I'm going to draw my basic cell again, but we're only going to care about the percent of water. So in this situation, let's draw our beaker again. So our beaker is just our fancy glass that's holding our solution. We still have a cell inside. However, let's say that this cell, the concentration of the water is 85%. And outside the cell, here's our mostly water, it was 90% water outside. So even though the rest of these solutions are made up of salts, only the water can pass this membrane. So with osmosis, only water can pass. So therefore, water will actually move into the cell because 90% is greater than 85%. Now, we can describe these different solutions with some terms. So because only water can pass during osmosis, this causes us to have different situations. And this is shown in figure 513 really well. So I'm going to draw three beakers here, and we're going to show the different types of solutions you can have. So here's beaker 1, beaker 2, and beaker 3. Here are three cells in each of our beakers. So here's our blue water, because the solution is still going to be mostly water. So in this particular cell, we're going to have 90% water and 10% salt. And in this particular cell, we're also going to have 90% water and 10% salt. So, which way would the water move this time? It's not going to move at all because we have 90% here and 90% here. There is no concentration gradient. For every one molecule of water that leaves, one molecule of water will come back in. While we look at water for what can pass, how we define the solution is going to be based on the solutes. This is called an isotonic solution. because the solute concentration inside the cell is equal to the solute concentration outside the cell. So we define our solutions and name them based on the solute concentration. But the only way we watch what happens to the water is by looking at the solvent concentration. That sounds confusing, I know, but it's something you're going to have to get used to. So in isotonic solution, we have the same solute concentration. Water is the solvent, salt is the solute. Solute concentrations equal, isotonic solution. Water will pass equally back and forth. Next scenario. So let's say we have inside the cell now, we have 95% water and 5% salt. And outside, we have 90% water and 10% salt. The water is the only thing that can move because water is 95% inside and 90% outside. Water will move out of the cell. This will actually cause the cell to shrink. This is a process that sometimes is called plasmolysis. And this is what we call a hypertonic solution. So this is hypertonic. So isotonic means equal, hyper means larger. The solute concentration outside is greater than the solute concentration inside. So in a hypertonic solution, the solute concentration outside the cell is greater than the solute concentration inside the cell. What you will notice is the water will always move towards the higher solute concentration. Remember, 95 was bigger than 90, and so water moved out. It will always move towards the higher solute concentration. So our third scenario would be the third possible way we could define our solution. It can be either isotonic, hypertonic, or hypotonic. And in this condition, it's going to be the opposite. We're going to have, let's say, 85% water inside the cell and a 15% salt solution. And in the outside, we're going to still have our same 90% H2O and now 10% salt. If we look at this, 90% is greater than 85%. So water molecules that are in the solution, they are actually going to move into the cell. They're also going to go towards the higher solute concentration. So here the 10% was greater, so they moved out. Here the 15% is greater than 10%, they actually move in. This can actually cause a cell, if it gets too much water in it, to burst. So the ideal situation is for all cells to be in an isotonic situation. This is equilibrium. If you get out of balance, you either get hypertonic or hypotonic. You have the chance of either shrinking, not being able to do what you need to do, or bursting, completely obliterating the cell. So this is a hypotonic solution. And so now it's the other way around. The solute concentration in the cell is greater than outside the cell. So that is probably the hardest concept, one of the hardest concepts students have with introductory bio. It's very important in the chemistry of understanding how we maintain homeostasis though. So we'll talk about this a few more times this year, but you'll also see this come into play when you get into A and P and micro and even genetics, because if your cells